In this video, we will discuss the new enhancements in SAP 2000 version 27.0.0. Let's take a look. For drafting and editing, a user mesh feature has been added for all areas and solids, allowing a user-controlled mesh to be imported from a DXF. We'll take a look at an example of this. Solid objects can now be generated using a selection of lines representing the solid edges. And for structural modeling, solid elements can now include nonlinear material behavior, and I'll show you how to define that. You can import and export OBJ model files that have been added to transfer geometry with external sources. A few concrete and steel frame design codes have been added as well, and I'll show you where those are located. Let's open up SAP 2000. First, we'll take a look at the user mesh feature, which has been added for areas and solids, allowing a user-controlled mesh to be imported from DXF. Let me show you where to find that. So if you go to Draw, Import User Mesh as Area, we'll select the DXF. We'll click on the 2D button to get a nice view of it. You can select the location, scaling, as well as rotation, and if you wanted to add any slab properties. We'll put this in a 2D view, and to see the mesh, we'll click on the Set Display Options. Under Object Options Areas, we'll click on User Mesh. We can fill the objects as well. So this user mesh will be utilized by the analysis for objects that have a user mesh defined. Let's take a look at how solid objects can be generated using a selection of lines representing the solid edges. So here we have a pyramid model. I'm going to select all the lines. Next, we'll go to Edit, Edit Solids, Create Solids using selected lines. Now, you can see the solid objects have been generated using the selection of lines representing those solid edges. And if we go back to the Set Display Options, we can click Extrude and take a look at the model. You can see the solids have been generated. Okay, now I'll show you how to import and export OBJ model files that have been added to transfer geometry with external sources. So we simply go to File, Import, OBJ file, and for import information you can select the global up direction, the units, as well as length tolerance, as well as max arc segment length. And here you can see the model has been imported. Let me show you how solid elements can now include nonlinear material behavior. So currently, a von Mises plasticity model is available and can be used with steel and other non-concrete materials. Just to refresh your memory, let me show you where that's located. Under Define, Materials, we'll pick a steel property, Modify Show Material. We'll need to switch to Advanced Property Display. Here, we can click on Modify Show Material Properties, and under the coupled nonlinear data, you'll see the coupled modeling type von Mises plasticity, as well as all von Mises plasticity parameters can be defined here. Now let me show you how to apply that to solid elements. So if we go to Define Section Properties, we'll click on Solid Properties. Add a new property. We'll pick a material that's steel. And for the formulation type, if you click on Standard, now this option to use nonlinear behavior has been enabled. Let me show you a little example. Here we're looking at a simply supported steel beam with an applied force on the square plate here in the middle. As it starts to yield, plastic deformation is occurring here at the bottom of the beam. And you can see that graphically right here. Next, let's take a look at the new design codes that have been implemented. If we go to Design, Steel Frame Design, View Revise Preferences, here in this pull-down menu are all of the codes that have been implemented. New ones including CSA S1619, as well as CSA S1624. Now for concrete frame design, we'll do the same thing. New codes that have been implemented include ACI 31825, Eurocode 1992 1-1 2023, as well as Vietnamese TCVN 5574 2018.